This is problems 8 and 9 of the radioactivity half-life homework 1. Problem 8 says the half-life of strontium-90 is about 28 years. How long in years will it take a 36 milligram sample of strontium-90 to decay to 15 milligrams? For method 1 of problem 8, I used the formula Nt is equals to N0 over 2 raised to the T divided by T half-life. So based off the problem, I plugged in NT, which is how much is left after the decaying period, and then I plugged in N0, which is how much you have initially. Then I divided that by 2 raised to the T over the half-life time, which is 28 years. And then after switching the place of these two, you can divide 36 by 15 to get 2.4 is equals to 2 raised to the T over 28 years. To get rid of the bases, you can take the log of both sides, and then you can divide log of 2.4 divided by log of 2, and then multiply 28 years over to get your final answer of T is equals to 35.4 years. Method 2, I use the formula NT is equals to N0 times E raised to negative lambda times T. One important thing to note about this is that you can replace negative lambda with negative 0.693 over T half-life, which in this case is 28 years. So then you plug in the same variables from the first method. 15 milligrams is equals to 36 milligrams times E raised to negative 0.693 over 28 years times T. You condense it by dividing 15 by 36 and multiplying T to the numerator of the exponent. After that, to get rid of E, you have to take the natural log of both sides, and then the natural log and E cancel out. So then you can multiply 28 over to the answer of the log of 0.4167, and then divide negative 0.693 to get T is equals to 35.4 years. Problem 9 reads, after 6,400 years of undergoing alpha decay, a sample contains only 6.25% of the radium nuclei initially had. Was the half-life of these radium nuclei? So I use the same formula for method 1 of problem 8. Nt is equals to N0 over 2 raised to T divided by T half-life. And since they don't give you the actual numbers of how much is remaining and how much you started with, you just have to use numbers that fit with the problem. So they say you have 6.25% left of what you initially had, and I know 6.25% of 100 is 6.25, so I just used 100 grams as my initial starting point. So then it's basically the same as the first problem from here. You plug in how much you have left, which is 6.25 grams, and then you set equals to 100 grams, which is how much you started with initially, over divided by 2 raised to the 6,400 years divided by T half-life. You can condense that by multiplying the exponent and the 6.25 grams and switching their position. And then you can divide 100 by 6.25, which is 16. And to get rid of both the bases, and after you're right here, you can take the log of both sides. And after you take the log of both sides, you can divide the log of 16 by the log of 2, and divide that what you got there. You can divide 6,400 by that answer that you got there to get T half-life is 1,600 years. Method 2, I use the same formula from method 2 of problem 8. Using the same numbers that I just said from method 1 of problem 9. We have 6.25 grams is equals to 100 grams times E raised to the negative 0.693 over T half-life. Remember, because you can convert the negative lambda. You multiply that by 6,400 years, and then you can convert. You can simplify this exponent right here, which is 6,400 times this, And then you can also divide 6.25 grams by the 100 grams. And then after that, you can take the natural log to get rid of the base of e. And from there, you multiply the t 1/2 over, and then divide the answer from the natural log into negative 4435.2 years. And that should give you t half-life is equals to 1600 years.